Right now, while you are sitting there watching this, the west-facing window in your living room is functioning like a magnifying glass aimed at your sofa. The sun is driving radiant heat through that pane of glass at a rate your air conditioner was never designed to keep up with. And you are paying $4, $5, sometimes $600 a month in the summer to cool a house that your own windows are cooking from the inside. I spent nearly $3,000 last summer fighting it and saved $68 on my bill. That is when I knew something was wrong. An $80 wooden screen, a design that master craftsmen in the old quarters of Cairo and Jeddah have been carving for 900 years, can cut the cooling load on any room by 21%. No wiring, no compressor, no contractor. A single carved panel over the west window, a ceramic water jar on the table behind it, and the hottest corner of your house becomes the coolest. In 2024, engineers ran the whole question through the United States Department of Energy's own simulation software. What they found should have ended the conversation. The code in your county was written by the same people who collect a check every time you turn your thermostat down, and they were never going to let the conversation end. I was sitting at the kitchen table in August of 2023, looking at an electric bill that said $612, and I told my wife I thought it was a mistake. It was not a mistake. My wife set her coffee cup down slowly, the way she does when she is trying not to say something. The power company had sent the right number for the right house for the right month. I had spent that summer doing everything the HVAC industry tells you to do. $2,400 for fresh cellulose blown into the attic in May. $350 for one of those smart thermostats that learns your habits. Reflective film on the south-facing windows, a duct cleaning I still cannot believe I paid for. An HVAC contractor who came out in July and told me my unit was running at about 68% of original efficiency. And would I like a quote for a $12,000 full replacement? My bill went from $680 the previous August to $612 this one. $68 of improvement for close to $3,000 of equipment and labor. That is when I went looking for the real number. The National Renewable Energy Laboratory had published it years ago in a technical report nobody outside the building science community ever reads. A west-facing window in July and August can reach an interior surface temperature of 160 degrees Fahrenheit. 70% of the solar radiant energy hitting that glass gets transmitted directly into the room behind it. That pane of glass was broadcasting heat at me like a toaster element while I stood in the kitchen paying $600 a month to fight it. And every modern American house has at least one. Nobody in the cooling business is going to tell you that because the cooling business does not make money stopping heat from coming in. It makes money selling you better ways to push heat back out after it arrives. A better air conditioner, a smarter thermostat, a more efficient compressor, a variable speed blower, every one of them built around a motor that wears out, a warranty that runs out, and a replacement invoice that arrives in 12 to 15 years from the same company that sold you the first one. They are not on your side, and they never have been. A carved wooden screen that stops heat from entering your house in the first place cancels their entire product line, and that is a problem they have spent 90 years making sure you never have to think about. I sat at that table that August and said out loud, there has to be another way to do this. My wife looked at me and said, maybe ask your son. He just got back from over there. At Thanksgiving, he told us something at the table that I did not understand for almost a year. My son finished his second deployment in the fall of 2022. He had been stationed outside Jeddah, Saudi Arabia for the last 6 months of it. On his final Liberty weekend, he and 2 other Marines borrowed a car and drove into the old part of the city, Al-Balad, the historic quarter. He told us about it at the Thanksgiving table while my wife was passing the gravy. 107 degrees outside. They had been walking 20 minutes when they turned down a narrow stone alley and saw an old shop with carved wooden screens covering every window on the second floor. The door was open. They stepped inside, and he said, Dad, I am not exaggerating. It felt like walking into a grocery store cooler. No compressor outside, no ductwork in the ceiling, nothing mechanical anywhere. An old man was pouring tea into small glass cups. My son asked him about the temperature. The old man did not speak much English, but he pointed at the screens and said, my grandfather. Then he pointed at himself and said, my grandfather. 6 or 7 times. The same 2 words across 6 or 7 generations. My son drank his tea, walked back out into the heat, and got on a plane home a week later. He moved on. I could not. 6 months after Thanksgiving, I was still thinking about a tea shop in a country I have never been to. I started searching, and a photograph from the 1890s stopped me cold. Every building in old Cairo, top to bottom in those same carved wooden screens, captioned with a name I had never heard, Hassan Fathi. Fathi published a book in 1973 that took me 3 weeks to track down a copy of. What it contained answered the question my son had raised at the Thanksgiving table. 18 months later, I would build one of these things myself out of plywood and cut my July electric bill by $156. A retired electrician in Texas I eventually drove 300 miles to meet had been running his for 2 straight summers and cutting his bill by nearly $300 a month. But I would not have believed any of it if I had not first gone looking for the name in that caption. Because Fathi's own life was what put the whole picture together. He was the man who tried to bring this technology back and watched his own country bury it. In the summer of 1975, Hassan Fathi was 75 years old, and he was walking alone through the ruins of a village he had built with his own hands almost 30 years earlier. The village was called New Gorna. It sat on the west bank of the Nile near Luxor, across the river from the Valley of the Kings. Fathi had designed it in 1945 at the request of the Egyptian Department of Antiquities to rehouse 7,000 peasants who had been living on top of the ancient tombs. He built it out of sun-dried mud brick, the same material Egyptians had used for 6,000 years. A dome ceiling on every house to vent hot air straight up and out. A wind catcher on every roof, a vertical shaft with angled openings that captured the prevailing breeze and funneled it down into the rooms below. And over every window facing the harsh west sun, carved wooden screens, the same kind my son had seen in Al-Balad 30 years before I would ever hear the name. The houses cost 1/10 of what the Egyptian government was spending on concrete block replacements. They stayed cool without electricity. They used no imported materials. But in 1975, Fathi stood in an empty square in the middle of that village and watched dust blow down streets nobody lived on. The peasants had refused to move in. The Egyptian government, under pressure from foreign aid donors and modernist architects trained in London and Paris, had redirected the rehousing budget to concrete apartment blocks of the sort being built in Cairo and Alexandria. The mud brick village was left to rot. But the story of what broke Hassan Fathi goes back 34 years further than Nugorna, to a specific street in Cairo. In 1941, Fathi was 41 years old and teaching at the Faculty of Fine Arts in Cairo. One afternoon he was walking through the neighborhood around the Ibn Tulun Mosque, the oldest mosque in the city, built in the 9th century. He stopped in front of a building he had known since childhood. A 4-story merchant's house from the Ottoman period, the facade carved top to bottom with wooden screens. He had drawn it as a student. He had photographed it for a class project. It was gone. In its place stood a half-finished concrete apartment block designed in the international style. Flat roof, steel frame, glass curtain wall, no shade on any facade. Fathi stood in the street and watched workmen haul the last of the carved wooden screens from the old house to a pile in the courtyard where they would be burned. He wrote in his journal that night that modern Egyptian architecture was committing a slow murder of the only thing Egypt had ever known how to do right, and he started sketching. Over the next 30 years, he filled notebook after notebook with drawings of traditional Egyptian houses, screens, courtyards, wind catchers, domed ceilings, evaporative cooling jars, every mechanism that 10 centuries of Cairo builders had refined for the climate they lived in. In 1973, he published the distillation of all of it in a book titled Architecture for the Poor. The book contained a cross-section drawing of a traditional Egyptian house that explained, in one image, how the carved wooden screen over the window created cross-ventilation, how the hot outside air was cooled as it passed through the lattice, how the airflow was slowed and turbulated by the intricate geometric pattern, and how a small clay water jar placed on a table directly behind the screen evaporated a tiny amount of water into the passing breeze to drop the temperature by 5 to 10 degrees before it reached the occupant. The screen had a name. It was Arabic. The root of the word meant a place of drinking. The name was mashrabiya. Fathi had not invented it. He had rediscovered it. The oldest documented mashrabiya in the Islamic world dates to 12th century Cairo, 900 years ago. By the 13th century, every merchant's house in the Red Sea port cities was covered in them. By the 15th century, Mughal emperors in India were having them carved out of solid marble for their private quarters. The technology was old, proven, and spread across 3 continents when Hassan Fathi picked up his pencil to draw it for a book almost nobody in Egypt wanted to read. He died in Cairo in November of 1989. His own country had spent the previous 40 years ignoring him. Foreign aid agencies that had once dismissed his designs as backward were, by the 1980s, quietly funding studies on passive cooling in the developing world that reproduced every conclusion he had published 16 years earlier. But one city on the Red Sea, 1,000 miles south of Cairo, never buried what Fathi spent his life trying to bring back. And what happens inside its old walls in the summer is what finally explained to me what my son had walked into that afternoon in Al-Balad. Al-Balad is the historic core of Jeddah, Saudi Arabia, the Old City. 7th century trading port on the Red Sea, once the gateway for pilgrims traveling to Mecca, now surrounded on every side by glass skyscrapers and concrete towers. But step into the old quarter and you step backwards 600 years. The buildings are made of coral stone quarried from the seafloor, 4 and 5 stories tall, packed tight along narrow alleys that never see direct sun. The windows on every facade are covered by a mashrabiya. The locals call them rawashin, the plural of roshan, the Arabic word for window. They project outward from the walls on wooden brackets, bay windows carved top to bottom with geometric lattices that you can see through if you stand right up against them, and can barely see through at all if you are standing across the street. The city has been building them for almost 1,000 years. The master craftsmen passed the knowledge from father to son the way carpenters in Amish country still pass down the craft of barn framing. I watched a documentary about one of them. His workshop sat off a narrow alley in Al-Balad. He was in his late 70s, a small man with hands that looked like polished wood themselves. He worked in Burmese teak because teak does not warp in the heat or rot in the humidity. He had been carving rawashin since he was 15 years old. When the filmmaker asked him how many he had made in his life, he looked up and thought for a long moment and said, "Enough to shade my city." He pointed at the pattern he was cutting with a small hand chisel. The pattern, he said, was mathematics dressed up to look like art. Every measurement was doing a specific job. The size of each hole broke up direct solar radiation, The angle of each cut accelerated the wind passing through. The spacing between the openings slowed and turbulated the air so it tumbled and cooled before entering the room behind it. He said his grandfather had shown him how to test a finished screen by placing a lit candle behind it on a day when there was wind outside. If the candle flickered in the correct rhythm, the screen was working. A flame that stayed still or blew sideways meant the spacing was wrong.
He did not learn any of this in a university.
His grandfather learned it from his grandfather, and so on back through 15 generations of men who knew how to cool a room in a city where the summer temperatures regularly exceed 110 degrees Fahrenheit. Then in 2020, two researchers from the University of Sheffield in England, Ahmed Bagassi and John Kaladat, published a field study in the journal Energy and Buildings that measured exactly what those 15 generations of craftsmen already knew. They instrumented a Rawasheen-fitted room in Al Balad and another room across the street without one. On a day when the outside temperature hit 106 degrees Fahrenheit, the room with the screen stayed at 93. The room without it hit 102. A difference of 9 degrees, with no electricity, no refrigerant, no moving parts beyond the wind itself. What Fathi had drawn in his 1973 book was buried by his own government, ignored by American builders for the next 50 years, and quietly confirmed by that Sheffield field study in 2020 that almost nobody in the United States has ever read. The Saudis were not the only ones who kept it alive. In the 1630s, the Mughal Emperor Shah Jahan was having a new fort built in Delhi out of red sandstone. Inside his private quarters, the Diwan-e-Khas, he had the masons cut lattices not out of wood but out of a single slab of white marble, pierced in geometric patterns so fine and so intricate that the stone screens look like lace. They are called jali. The purpose was the same: cool the air before it reached the emperor. 220 years later, when British forces occupied the Red Fort in 1857 during the Indian Rebellion, the British officers documented in their own letters that the rooms behind the marble jali stayed measurably cooler than the quarters they had commandeered across the courtyard. They wrote it up as a curiosity of Oriental architecture, filed the letters, and went home. In Granada, Spain, Moorish craftsmen were carving the same kind of screens into the walls of the Alhambra Palace in the 1300s. They called them celosia. Different word, same physics. UNESCO designated Al Balad a World Heritage Site in 2014. The official citation described the Rawasheen as a feature of outstanding universal value. But a French architect had already done something with the same principle 16 years before the UNESCO designation, and nobody in America seems willing to talk about it. On the evening of December 10, 1987, the French architect Jules Nouvel stood on the Quai Saint-Bernard in Paris as a new civic building he had designed came alive for the first time in public view. French President François Mitterrand was on the steps. Photographers crowded the opposite bank of the Seine. It was called the Institut du Monde Arabe, the Institute of the Arab World. The wall that received the direct Mediterranean sun was covered with 240 motorized panels. Each panel was a square steel frame containing a mechanical iris of the sort used inside a camera lens. 60,000 individual apertures in total, all of them opening and closing in real time in response to a computer reading the position of the sun. It was a mashrabiya. Nouvel said so himself, in interviews, on the record, in every architectural review of the project that was published between 1987 and 1990. He said he was translating the 900-year-old Arabic screen into the language of modern engineering. The French government paid approximately 230 million francs to build it. It won awards. It became one of the most photographed buildings in Paris. The mechanical facade never worked quite right and has been largely turned off for decades, but the principle it was built on has been taught in every major architecture school in Europe ever since. Western architects know about mashrabiya. European civic buildings have incorporated versions of the principle for 40 years. Germany has whole neighborhoods of homes fitted with modern versions. The Pritzker Prize, the highest honor in world architecture, has been awarded to 3 architects whose work centers on passive cooling techniques drawn from Arab and Mughal traditions. But in the United States, you cannot get credit for one on your building permit. The American code that governs how new homes are built is called the International Energy Conservation Code. It is written and updated by a committee called the International Code Council. Their recommendations are turned into enforceable law by your state legislature and your county building department. The code has a section on fenestration, which is what architects call the holes in your wall where windows go. Your builder gets credit for a higher performing pane of glass, a better seal around the frame, a low emissivity coating that reflects some percentage of infrared radiation, and every one of those credits is for a product manufactured and sold by a company with a lobbying budget. There is nothing on the form for a carved wooden screen, no line item for a porous lattice mounted in front of the window, no category for passive solar shading that sits on the exterior of the building and uses no electricity to operate. The mechanism is not in dispute. Modern European laboratories have verified the physics. The 2020 Jeddah field studies documented it in the real world, and 400 years before the first thermometer was invented. Mughal emperors were cooling the marble rooms of the Red Fort with it. But if your builder installs one on a house he is constructing in Texas or Arizona or Georgia, he gets zero credit toward the energy code. The screen does not exist on his calculations, and the whole thing is invisible to the inspector who comes out to sign off. Who sits on these committees? Representatives from the heating and air conditioning industry, from window manufacturers, from insulation companies, from utility companies. from the National Builder Associations whose member companies install mechanical cooling in every home they construct. Passive cooling has no trade association, no lobbying budget, no seat at the table. A screen that eliminates the need for an air conditioner is not a product the air conditioner industry has any reason to recognize. In 2024, a team of building scientists ran a parametric study using Energy Plus, the simulation software the United States Department of Energy itself developed and distributes for building code analysis. They modeled the installation of traditional mashrabiya screens on residential buildings in hot climates. The result, published in a peer-reviewed engineering journal, was a 21% reduction in annual cooling energy consumption. The Department of Energy's own tool, using its own approved methodology, confirmed the effect. The code has not changed. It is not going to change. The system was not designed to cool your house. It was designed to sell you cooling. While the American code pretends the mechanism does not exist, the Louvre Abu Dhabi sits under a dome modeled on a mashrabiya. The Doha metro stations in Qatar are built with mashrabiya-inspired louvers. The King Abdullah Petroleum Studies and Research Center in Riyadh, designed by the British-Iraqi architect Zaha Hadid, has a mashrabiya facade. Every major civic project in the Arab world built in the last 20 years incorporates the principle, and the engineering firms doing the work are often American and European. The same companies that will not put one on a single house in the United States are installing them on billion-dollar foreign projects and collecting consulting fees for the privilege. The knowledge was never lost. It was just kept on one side of an ocean. If you are sitting there in a house you already own, 30 or 40 years old, and you are thinking this is about new construction or architects or people who can afford to remodel from scratch, stay with me. This part is for you specifically. You do not need to touch your foundation or get permission from your HOA or hire a contractor. You need one weekend and about $100. Here's exactly what I did, and then I want to tell you about the retired electrical contractor I drove 300 miles to see. In June of last year, I measured the surface temperature of the inside pane of the west-facing picture window in my living room at 4 in the afternoon on a 98-degree day. It read 94 degrees Fahrenheit. The drywall next to the window was 86. The air in the middle of the room was 82. Cold air from my central air vent was pouring onto my feet. Heat was pouring off that window onto the top of my head. And the thermostat on the wall thought everything was fine because it was 12 feet away from the actual problem. The window was 48 inches wide by 60 inches tall. I called a local woodworker who did custom cabinet work and asked him if he could laser cut a piece of 3/4-inch marine plywood in a traditional Arabic geometric pattern. I sent him a reference image pulled from Hassan Faithi's 1973 book. He had it done in a week for $95. I picked it up on a Saturday morning, stained it a dark walnut with an exterior grade oil finish, and mounted it on the outside of the window with 4 stainless steel L brackets into the window casing, leaving a 2-inch gap between the screen and the glass. The brackets and hardware ran me $18. I bought an unglazed terracotta Ola pot at the garden center for $34 and set it on a small table on the inside of the room behind the window. Kept it half full of water. 2 weeks later, same time of day, same outside temperature, I measured again. The interior surface of the glass read 79 degrees. The drywall next to the window was 75. The air in the middle of the room was 72. I turned the thermostat up 3 degrees and the central air kicked on less than half as often. My July electric bill was $391. The previous July it had been $547. A reduction of $156 in a single month, from a piece of plywood, 4 brackets, and a garden pot. I wanted to know if it held up over time. So I drove to Kerrville, Texas, in the hill country west of San Antonio, to see a man named Raymond Holbrook. Raymond is 68 years old, retired electrical contractor. He built 2 panels for his own house in the spring of 2023 out of half-inch cedar he had in his shop from an old fence tear-out. He cut the geometric pattern himself on a scroll saw. Took him most of a weekend. He mounted the panels over the 2 west-facing windows in his living room and set a clay water jug on the floor between them. Raymond keeps a handwritten log of his electric bills going back to the year he bought the house in 2001. He let me sit at his kitchen table and read through it. His August bill in 2022, the summer before the panels, was $468. 1 year later, after the panels went up, it dropped to $187. In 2024, with the panels in their second full year, it held at $174. A reduction of nearly $300 a month, sustained over multiple years, on a single home improvement that cost him less than $40 in fasteners because he already had the wood. I asked him why nobody talks about this. He poured me another cup of coffee and said, because nobody is selling it. Then he said the things that last never have a salesman. The Energy Plus study said 21% reduction in annual cooling energy. Raymond Holbrook was running about 60% reduction in peak summer months. My own numbers were closer to 30% over a full season. The range is real, and the variation depends on your climate, your window orientation, the size of the screen relative to the glass, and whether you use the water jar behind it. No serious installation anyone has ever documented has shown 0 reduction. Not one. The materials are at any home improvement store, the design is in any book on Islamic architecture, and the math was published in a United States Department of Energy simulation tool in 2024. The only thing between you and a measurably cooler house next summer is a Saturday and about $100. The west-facing window in your living room is, right now, still sitting there, still absorbing sunlight, still broadcasting heat into a room you are about to pay your power company to fight. The window is not going to change, the sun is not getting cooler, and the county building code is not about to start recognizing 1,000-year-old Arabic technology. What hangs in front of that glass is the only thing in this equation you get to decide. Hassan Fathi drew the mechanism in a 1973 book his own country ignored for 20 years. The craftsmen of Al-Balad had been carving them since before the Crusades. The Mughal emperors cooled their palaces with them 400 years ago. A French architect wrapped one in motors and sold it to Paris for 230 million francs. And a retired electrical contractor in Kerrville, Texas, built one out of scrap fence cedar in a weekend and cut his summer electric bill by more than half. If you are the kind of person who believes that real knowledge has been quietly set aside to protect someone else's profit, you already understand what this video is. The pattern is always the same. A cheap solution works, gets noticed by the industry it threatens, and quietly disappears from the approved list. You end up paying for the expensive version for the rest of your life. Tell me in the comments what state you live in, and which direction your worst window faces. The one you can feel the heat coming off of in August. I am reading every one of them, and I am building a map of where in this country people are paying the steepest price for a code that pretends this solution does not exist. Hit subscribe if you want to keep pulling on these threads with me. Next week I am breaking down the $200 backyard system that can power an entire home on nothing but firewood. A technology that ran 500,000 vehicles across Europe during the Second World War. A man in Alabama who has driven his trucks more than 500,000 miles on fuel he cooks in his own backyard. And the exact construction manual for it sitting inside a 1989 FEMA document almost nobody has ever opened. You are going to want to see that one.